Hey, all right. We are working 2.6b homework solutions. These are some classic related rate types problems. And we're starting on page 146, number 20. So let's just bring that into view. It says the formula for the volume of a cone is 1/3 pi r squared h. Find the rate of change of volume dr dt if dr dt is 2 inches per minute and h equals 3r when r is 6 inches and r is 24 inches. Okay, so as long as we can get part A, part B is easy. It's just plugging in a different number. Okay, so number 20, what do we want? Well, it says find the rate of change of the volume. So that would be dV dt. What we know is the rate of change of radius is equal to 2 inches per minute. Now we relate volume to radius with the volume formula of a cone. 1/3 pi r squared h. However, we have too many variables here. We would have too many unknowns. We know that h is equal to 3r, so I could plug 3r in for h right there. So I have volume is equal to 1/3 pi r squared times 3r. The 3's will cancel, and this formula simplifies simply to pi r cubed. And I can take the derivative of that with respect to time. So that's dV dt is equal to 3 pi r squared. So many times students forget to put the squared there. Times dr dt. It's rare for a student to forget the dr dt because you know you have to plug that in to solve the problem. Okay, so we want the rate of change of volume, so we can just plug this in. It's going to be 3. So for part A, it would be 3 times pi. It's when the radius is 6 inches. Got to square that. And the rate is 2 inches, dr dt, 2 inches per minute. Okay, so 3 times 6 squared is 36 times another 2. And that's going to be 216 pi. And you'd have inches cubed per minute. So cubed being a volume unit. And then B, for part B, we just replace the 6 with a 24. All right, and that's 3,456 pi inches cubed per minute for part B. So all the work is in part A. All right, so if you need to pause the video, go do that, and we'll get on to number 21. Okay, 21 is another problem with a cone. So that one says at a sand and gravel plant, sand is falling off a conveyor and onto a conical pile at a rate of 10 cubic feet per minute. The diameter of the base of the cone is approximately 3 times the altitude. So altitude is just the height. At what rate is the height of the pile changing when the pile is 15 feet high? Okay, so this time, at what rate is the height of the pile changing. So what we want is dH dt. What we know is it says 10 cubic feet per minute. Well, cubic feet would be a volume. All right, we're still going to use that volume of a cone equation, 1/3 pi r squared h. Now this time we know that the diameter of the cone is equal to 3 times the height. That means radius is half of the diameter, so that would be 3/2 height. And I want to get rid of radius, so I'm going to plug in right there. We need to keep height because we're solving for dH dt. That'll get us down to just two variables. So I have volume is equal to 1/3 pi. We're going to substitute in 3/2 h. But we've got to square it, right? Because r is squared, times h. So that's going to be 1/3 pi. 3/2 squared would be 9/4, and then we have h squared times h cubed. So let's clean that up one more time. 9/12 would be 3/4 pi h cubed. So now I can take the derivative of that finally. So really a lot of the work of this problem is just algebra. And the same was true on the last one. So we have dv dt, but there's a lot of algebra and calculus. 3 times 3/4, that would be 9/4 pi h squared. Don't forget the exponent. Then times the derivative of h, which is dH dt. So solving for dH dt, I'm going to bring that 9/4 pi h squared underneath dv dt. Okay, goodness. Now we can finally plug some numbers in. dv dt we know is 10. 9/4 times pi, and then the h is 15 feet. And don't forget to square that. So if you put that in your calculator, be careful. You might want to do the denominator all by itself, and then 10 divided by that. The book keeps it as a fraction in terms of pi, but it's probably easier if you just do this decimal-wise, 0.006 feet per minute. That's perfectly fine with me. If you reduced it, it's 8/405 pi feet per minute. And probably that's what the back of the book gives, but goodness, this is perfectly fine. Okay. All right, so that's 21. That one I work every year for students without fail. But I used to not give any hints, so giving you hints hopefully helped some. Okay, 25A, we've got the ladder problem. So a ladder is, so you can go right back to your notes to see how this is done. A ladder is 25 feet long, leaning against the wall of a house, so that's this figure 25 right here. The ladder is pulled away from the wall at a rate of 2 feet per second. So they've even got the arrows here. showing that. And how fast is the top moving down the wall when the base of the ladder is 7, 15, and 24. So really all the work is, let's just find it for 7, and the rest of it is just a matter of plugging in. So I'm going to go ahead and draw this. We've got our ladder. The ladder is 25 feet. Let's call that X. We'll call this Y. And the base of the ladder is moving at 2 feet per second. So what we want is the speed at which the top of the ladder is moving. And that would be dy dt. So it's not the same speed until it gets to a 45-degree angle, and then it would be the same speed just for that moment. What we know is that dx dt is equal to 2 feet per second. And no fancy formula here. This is just a right triangle. So we use Pythagorean theorem. X squared plus y squared is equal to 25 squared. And we're going to differentiate that with respect to time. So that would be 2x dx dt plus 2y dy dt is equal to 0. We're going to solve for dy dt. So we would have 2y dy dt is equal to negative 2x dx dt. The 2's will cancel, and you would have dy dt is equal to negative x dx dt over y. So part A is when the base of the ladder is 7. So you could get, you're going to have to get the y value there. So if you use the Pythagorean theorem, y would be square root of 25 squared minus 7 squared, which is 24. So dy dt would be negative 7. Dx dt is 2. And then y is 24. And let's make sure you get your units right. If you need to write your units out, go ahead and do that. But it'd be feet times feet per second over feet. All right, and that is going to be negative 7/12. And if you did that decimal wise, that's fine. Feet per second. All right, and part B, we would just change 24 there, and it would be 7 instead of 24. So you just change the numbers as you needed to. When the base of the ladder is 15, what is, go through Pythagorean theorem, but dy dt for part B would be negative 15 times 2 over 20. So y would be 20 when x is 15. So that's negative 15 over 12 feet per second. Let's see, that's not right, is it? Let's see. That'd be negative 30 over 20, so negative 3/2. All right. And then part C would be negative 24 times 2 over 7. All right, so that would be negative 48 over 7 feet per second. Okay, and we're going to use that negative 7/12, so dy dt, I'm going to write that up here. Dy dt is equal to negative 7/12. And then we can go ahead and do 25b. All right, so 25b says, consider the triangle formed by the house, ladder, and the ground. Find the rate at which the area of the triangle is changing when the base of the ladder is 7 feet. So what we want is dA dt. What we know is that dx dt is equal to 2, and dy dt is equal to negative 7/12. So we know two pieces of information there. And we're going to need both of them. So to relate, I mentioned this in the hint, we know that the area is 1/2 for a triangle, base times height. So that would be x times y. And if we take the derivative with respect to time, dA dt, so this is a product rule. It's the first, 1/2 x times the derivative of the second, dy dt, plus the second, y, times the derivative of the first, 1/2 dx dt. So let's clean that up a little. dA dt, maybe factor out a 1/2, and you would have x times dy dt plus y times dx dt. And now we can plug in. X is, in this particular case, it was 7. So when the base is 7 times 2. Plus y was 24 when x is 7. And dx dt, oh, excuse me, that was dy dt. Sorry about that. Negative 7/12. And then dx dt is 2. All right. So that will give you, if you put that in decimal form, 21.96. So the book probably leaves that as a fraction, but be feet squared per second. Remember, area has a unit squared, and then time is second. So you can think of the units going to be, what's the unit for area? What's the unit for time? Area is going to be something squared. Time is going to be per second. All right, that does it for this homework set. I hope that was helpful to you, and I'll talk to you next lecture.